The simplest receptor is the free nerve ending. They respond to many different types of stimuli. For example, pain can be stimulated by chemicals, pressure or temperature or trauma. Nociceptors are pain receptors. They have large receptive fields and do not adapt quickly. There are two types of axons that carry pain information. Type A you might think of as for acute pain, and unmyelinated type C for chronic pain. Type A is fast pain. Sensations will quickly reach your conscious awareness and may trigger a reflex. We can usually localize where that stimulus is coming from. These are myelinated type A fast pain fibers. Type C fibers are unmyelinated, and the pain may be more of an aching general sensation. You're aware of the pain, but may not be quite aware of where that pain is coming from. So think of the initial pain of a sprained ankle that's fast and intense and localized. That pain is carried by type A fibers. But a week later, that becomes a dull, nagging, generalized aching carried by the type C fibers. Thermoreceptors detect temperature. There are many more cold receptors than warm receptors. These are free nerve endings in the dermis and muscles. Chemoreceptors respond to chemicals. Mechanoreceptors respond to physical distortion of the plasma membranes. They have mechanically gated ion channels that open or close in response to compression, stretch, twisting, and there are basically three types of mechanoreceptors: proprioceptors, baroreceptors, and tactile receptors. Proprioceptors monitor the position of the joints in our muscles. For example, the muscle spindle that we became aware of during the reflex chapter of the patellar reflex. Baroreceptors detect pressure, changes in blood vessels, in the respiratory tract, urinary tract. Tactile receptors provide sensation of touch. There's fine touch that's very sensitive and crude touch that's difficult to localize. Receptors can also be categorized by the nature of their response to stimulation. Tonic receptors are slow adapting. They're always active. So if you look down here at this graph, you can see the frequency of action potentials. This is the normal state, a steady action potential. But once there's a stimulus, the increased action potential frequency occurs. They're slow adapting and always active. Phasic receptors are fast adapting and normally inactive. So you can see there's no action potentials here until there is a stimulus. They're active for a short time when a change occurs in whatever it is that they are monitoring. Adaptation is, it basically reduces the amount of information reaching the central nervous system. There are two types of adaptation. Peripheral adaptation occurs when the level of the receptor activity changes. The receptor first responds strongly, and then the activity declines. For example, if you don't necessarily notice the temperature of a room until it changes. Central adaptation occurs along sensory pathways. It involves inhibition of nuclei along a sensory pathway, but you notice when you smell a new smell, once you detect it, then within usually less than a minute, that you no longer smell that smell. You're no longer aware, even though the neurons are still sending the signal of that smell.